Hello friends, this is Umesh, and in this video I will show you how to design a PCB printed circuit board PCB board file using Eagle CAD. So if you remember, in our previous video we have learned how we can design um, a circuit onto the schematic sheets, and now it's a turn we can convert this schematic file into the board file so that we can generate the Gerber files, also to say output files, and send it to the board house and produce the printed circuit board. So to convert the schematic into the board file, what we have to do is we have to hit on this button. I don't know if you can see this upper menu bar. It's it asks you to create the board file. So let's hit on this icon, and it will pop you up this box which will say like this voltage regulator.brd file doesn't exist, and if you want to create, so we want to create, so let's hit on yes, and it will generate the board file for you, and it will pop up this new board file. So let me maximize the screen, and as you can see right now, here is the board file. What the first thing we have to do is just to save this board file. So it will save this file with .brd extension, which is nothing but the board file, into the Eagle, and then hit on save. So now what you can see is the board file for us. So the first thing is to turn on the grid so that we can understand that what we are doing, and we would have the plenty of space to work around. So right now the grid is turned on. So most often time I prefer to give it the board size first, and then I place the components onto the board. So let me put the board size. So let me resize the board. So this is let's say I want this to be 40 by 50, and since the grid is millimeter, so it's very easy for us to measure this. So if I take this upper corner of this, and if I put my mouse cursor, I can see the dimension of the board is 40 by 50, and this is the right dimension for me. I just feel comfortable with it. You can make it even more compact design if you want, but this is just a tutorials, and I don't want to make it very compact and make it very difficult to understand, and play a little bit around the components. So I have decided to make it simple for this tutorial. So the next step is to take each and every component and place onto the board that we have resized. So first of all, I would like to tell you that you can see there are a couple of yellow wires that's been called as air wires. They're connected to the each and every components that we have in our schematic sheet, and these air wires are basically gives us the direction that how the component has been connected to each other. Okay, so we will see about this and we will talk about this later on, but first of all, let's put the component onto the board. So let me take this DC jack and put onto the board. Okay, then I can take the switch and put in here, um, and then check the voltage regulator IC, capacitor, then the diodes. You can just place the components right now. Don't just think about too much about the placements and all. We will make it more precise later on, as and when it's needed. But right now we just have to manage the components onto the board, and then later on we would make it much better than what it looks like right now. So don't worry about that. you can place the component as you like. Just don't focus more on it. You can optimize it at the way you like, the way you want it. But just for right now, I don't think this is such a bad idea to rush it quickly and then just make it more readable. So right now we have place all the components onto the board size that we have selected for our board. So let me hit on this very interesting button which is called zoom to fit in upper menu bar. So let me click on that, and you can see it will fit into the screen, and we can see the better view of the components. And you can even work a little bit around and make the grid more readable. I can say let's say if you really want to go deep, then you can make the 0.2 millimeter grid, and you can have even more finer control over placing the components. You can do if you want. I can just show you a couple of tricks which you can use for your optimization, but usually these things are just the just it just depends on how much time you spend on your board and how precisely you want to make it much better and readable for somebody who looked at your board file and feel like it's really enough. So if you feel like this capacitor would be very close to the diodes, you can drag this little bit down, and that will be okay. Okay, now I think this is enough, and let me hit again on Rasnets, and that's all what we have to do. The next step is we have to define the net class for the board. So go to edit and hit on net classes, and you can just put the default net class that most of the board house can allow us. Make the width for 12 mils and drill is 20 mils, and clearance is 10. This is very standard, and most of the board houses can allow you to go with this kind of specifications or net classes specifications. So I'm just happy with that, and I just hit on OK, and that's fine. If you don't have that, then put the numbers there, and you will be okay with that. So the next step is we can route the entire PCB file manually, or we can use the auto router. So I will dedicate entire separate video which will talk about how we can manually route each and every part of the circuit board. But for right now, I think it's good idea just to run the auto router trace and show you that how it's been done, and that would be, I think, the good idea, to instead of doing everything and just do it. So to run the auto route and make the PCB routing, you have to click on this option, which is auto router, and it will give you this new pop-up box. And since this is this board, I want to make it a double-sided PCB, so I'm happy it's not very complicated and something that you have to optimize it. So I'm really happy with whatever the auto settings they have, but you can set your layers. Later on we will talk in future videos that how it can be done and something like that. Then you can choose the effort, the level of optimizations. It could be the low, medium, high as you want, but for me low is okay. I'm happy with that. And maximum number of running threads. So in the new version of Eagle, it allows us to run the different threads, so that you can have the different level of optimizations, and you could have the choices that which you would like to finalize after routing. So so right now it's okay for me, it seems okay for me. So let me hit on continue and move on to the next part. So right now, after hitting continue, I get this pop-up box which is a routing variable or something. So it shows like nothing is happening. You can see down right corner there is a 0% and nothing is running here. So what you need to do is you need to hit on the start button, and it will start routing. So this board is very simple, so you have to be very focused to get exact routing process, that how it is happening. So let me hit on the start, and you can see it is 100% right now, and it is going on this routing, and it is still optimizing. And right now you can see we have the plenty of choices. There are few uh, there are couple of few choices we have right now. It's been auto optimized, and you can click on each and every one, and you can see the way they have routed the board. Okay, so you can see what which one you will be happy to go with, or you want to finalize it. So accordingly you can just do. So for me, I think this one is with one vias is, it's always good practice to not use vias, but that's okay. I can use this one, and then I can evaluate. And if you want to move further and do the further settings, you can uh, use this greater than sign, and you can get this few more options where you can optimize it if you really want. But I just don't feel that it's really important for me. Let me see once that this optimization is fine or not, so that I can finalize something. Okay, this also seems to be better for me, so I would go with the fifth one, optimized, zero vias and something, and I can hit on evaluate, and that would be okay. So right now, what I see is the circuit board which has been auto routed, and I don't have to run the manual traces. But if you want, you can run later on. We will dedicate the entire new uh, session for that, and that's fine. So this is okay. So the next step, and very important, is to put the ground pour into that. So let me hit on this ground pour, and um, we can run the ground traces here. So first of all, choose the top layer, and then choose the one point of the board, which is this one I would prefer to go with. And let me hit on this zoom to fit. This is very handy option. You can use it very often. And otherwise, okay, no worries. It's okay. And to come to the point where you have started, so once you hit on that, it will show you this things dot dot sort of thing. So go to names option and give the name to the port that we have inserted. It's a GND, it stands for ground, and hit on OK. And as you can see right now, you have given the name to it, and then click again zoom to fit. Sorry. And then later on again go back to the the ground pour, and now you have to choose the bottom layer, and put the ground plane onto the bottom layer as well. So start from the same point where you have started last time, and then finish it off, and go back to the name options again, and give the name to your newly inserted ground plane for the bottom layer. Again, give it the name as a ground, and hit on OK, and then hit on zoom to fit. And now you can't see the effect of that until you hit on this Rasnets button. So let me hit on Rasnets button, and you can see right now, you can see the complete circuit board for you. Now in the new version of Eagle, it's not very readable, so I'm not very happy with that. So what you can do is the one thing that I always love to do is I used to see um, the DRC, check if there is any error. So it's very handy, DRC check. So let's hit on this. It stands for design rule check, DRC. So let me hit on that, and I just hit on check, and it doesn't show any error. It says like DRC no errors. Okay, so this is a good news that we don't have any sort of error in that. The one thing that I would like to do is just go to the layer settings in the sidebar pane, and the one thing that I always love to do is I just disable the value layer, T value, and so you would not see the ugly stuff here. I just hope. Okay, this one I want to make it off, and then I just apply, and right now there are very few names on this, so I just use this smash tool and smash and hit on every component's origin point so that I can move the names around on that. So each and every components I prefer to hit on that so that I can move the names around, and that will be okay. So another things you can do is you can change the name of T place and B place to the white, which I usually do into the new version of Eagle, white one. Hit on OK. Okay. Also, I would like to change the DDocu. It's another layer which is very important, and I often like to make this DDocu as the slightly, bold green color. That's what I love to do. Okay, and just hit apply and hit on OK. And right now, as you can see the exact placement of your components and even the footprints. The one thing I still do not understand is the names of that. So I think we also have to change the name, this T names. And I also would like to make it white because I want it to be more readable. Okay, so now you can see I just take the move components and just take the name and put it properly where it looks a little bit better than the previous one. Move all the labels or the name of your components parts, so to say. You can just do it as you like. You can make things anyways the way you like, especially here. This is LED. You can give it the name, or you can go to the info section and then hit on that, and then you can even change the size of that. And this looks a little bit very big, so I make it a little bit small, so it will help me to fit into the place that I have. Okay, right now it fits very well. So this is how you can change um, the size of the label that you have, and you can also change the label for this one. Let me go back to zoom to fit and then take this resistor as well and put in here. You can play a little bit around this. This is not very important. Apart from that, one more thing you can do is you can give it the name. You can give it any name to your PCB, maybe the version that you want. So what I would like to do is I just want to give it the name to this PCB as like voltage regulator circuit VRC version 1.0, and this will be on the this will be often it's like a T place is a layer which you have to do. Right now it's on the on the bottom layer, and that is why you can see it's a mirror image. So I can use and select this T place. So right now you can see it's I can even change the font as a vector, and that will fits very well, I hope so. Okay, and I would prefer to put it here. You can put it anywhere you want, as you like, but since this board is very compact, I would like to put in here, so that will be the identity of the board. So this is how you can make this PCB, and this is, I think, almost this board is ready to to make it for the design the Gerber files. So let me save this board file, and the next step is to create the board file for this PCB. So our printed circuit board is ready, and now we are ready to create the output files. To create the output files, what we need to do is we have to um, go to another option, which is the CAM processor. You can see on the upper menu bar. So we can hit on this CAM processor and then go to file, and then open, and then select the jobs. And in the job we can have the several files, but the one that I will be using to generate the Gerber files is the one that is from the Spark Fun, and it's been modified by Jeremy Plum. So if you are wondering where to get this file, you can see in the YouTube description box. I would have left the link for the blogs. In the blog, you can see the GitHub link, which from where you can download, or you can download from the GitHub as well. So don't worry about that, you already have that. So just select the file that you want to run, the CAM file, and hit on open, and I think this is okay. We can choose the Gerber 27X, and these are the different layers that we want to create an output files for. There are different layers that, or the files that will be generating. Of course, that we will see later on how it can be done, and what the extension for that. So the setting is almost done, and what you need to do is just hit on the process job button, so it will generate the Gerber files for the board that we have designed earlier, and that files we will use. If you can see right now, if I show you in into the project directory, I can't see. Okay, so here it is. As long as we have not hit the process command, we can see only here. We can only see the board file, and this board file, and the schematic file, but there is nothing else. But as soon as we hit on this process job uh, um, option, we would get the extra um, some more files that will be the output file. So let me hit on the process job, and since the board is very simple, it doesn't have any complicated stuff. It just finished in just a second and two. And now if I go back and revisit, you can see there are more files has been created here. Okay, you can see early on there was only the board file and only schematic, but right now you can see this GBL, GBS, and GTL, and all sorts of files are there. So let me take you back to the folder where we have the file. Okay, this is the project, and as you can see right now, this all files, especially the files that has the extension with the capital letters GBL, GBS, GTL, GTU, and stuff like that. So what we can do is we just take all the files with the extension of the capital letter, and don't forget to copy this .txt file, because this is the drill file that we need. So we just um, cut this and create a new folder in the same file, and we can give it the name Gerber, and we can paste all those Gerber files here. So basically these are the Gerber files we need to send it to the board house, and in the next video I will show you how we can measure and optimize the uh, board, and see that if there isn't be any problem, there isn't be any track which touch to each other, and there is nothing like short circuit or something like that onto the board, and we will discuss more about that. So now I think at this point you are ready to design your circuit board from scratch, and the next video we will talk about how we can, you know, make sure that the board that we have designed, the files that we have generated, they are, you know, ready to manufacture, and we would not run into any problem when we actually get our board done from the PCB manufacturer. So I hope you will find this video educational and entertaining. See you in the next video. Thank you. Bye bye.